Alright, in this video what we're going to do is we're going to be talking about cube roots and how to handle higher order roots. Now, everything you know about square roots holds true. So, the way that you multiply these two things together, or you don't, or the way you multiply these two things together, or the way that you, can reduce, all those things hold true, provided that this thing right here is the same. So like this right here would be the cube root 35. Now this thing right here, this is called the index. And the index tells you, well, it tells you what kind of a perfect number you're looking for. So like this is called cube root. Cube root of 8 happens to be 2 because 2 cubed equals 8. You see, that's how it works. If you had the fifth root of, say, 32, that would equal 2 because 2 times 2 times 2 times 2 times 2, 5 of them, 1, 2, 3, 4, 5, yep, 5 of them there, that equals 32. This thing right here, it's asking what number times itself 5 times equals the radicand. That's how these things work. So everything you know about square roots, it still holds true. They're all kind of still the same thing. It's just you're looking for a higher power. So for example, let's say that we wanted to talk about the cube root of 8 plus, let's do 18 plus the cube root of 9. These two things, they're not the same. They don't equal the cube root of 27. However, cube root of 18 plus the cube root of, the cube root of 18 plus 9, well, that would be the cube root of 27. And the cube root of 27 is just 3. See, in order to be able to handle perfect cube roots, you need to know what the perfect cubes are. So they're 1 and 8 and 27, that would be 3, and 64 and 125 and 216 and 343, and I think it's 512, and then 729, and then 1,000. The only one I'm not really sure about is 512. So let's take a look. Let's pull up the calculator here. There we go. Alright, let's slide it over so we can take a look. 512, so that'd be 8 times 8 times 8. 3 times equals, dang, 512. Better lucky than good any day, right? So anyway, if you're asked for a perfect cube of, if you're asked for a cube root of, say, one of these numbers, like 216, well, you're being asked to find what number times itself 3 times equals 216, so that would be, of course, 6. Now, you know how with a square root, if you had a -4, that's imaginary, it's not a real number. And the reason it's not real is because -2 times -2 equals +4. There's no number times itself that equals a -4, not a real number anyway. Well, it doesn't quite work that way with cube roots. You see, this equals -2 because -2 times -2 times -2, well, this would be 4. And then multiplying by the other -2 would give you -8. You see, if this index is an odd number, you can have a negative radicand. But if this index is an even number, then you cannot. That would be imaginary, not real. Well, there we go. Imaginary, not real. Now, one thing about writing an index, people often write it like this, and these are two different things. This is the cube root of 4 over here, but this is 3 times 4. So when you're writing these by hand, you have to be very, very careful. The fifth root of 9 is different than 5 times the square root of 9. A lot of times people write this when they mean this, and they're totally different things. So you have to be careful. You have to be careful that the index goes right here. It's kind of like a little pocket right there in the radical symbol. There's like a little pocket. And if there's not a number written there, if there's nothing there, it's a 2. It's just assumed to be a 2. Okay, now, the last thing we're going to talk about is rationalizing the denominator. Let's say we had 9 divided by the cube root of 3. Well, if it was 9 over the square root of 3, all we'd have to do is multiply by the square root of 3 over the square root of 3. Now this equals 1, of course, and you'd get 9 root 3 over 3. You see, 3 times the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. This could be reduced, so you'd be left with 3 root 3, right? But it doesn't quite work like that with the cube roots because, well, check this out. If I multiply this right here by the cube root of just 3, then I end up with 9 cube root 3 divided by the cube root of 9. 9's not a perfect cube. That doesn't really help. So what I need to do instead, if I had 9 divided by the cube root of 3, what I would need to do is I would need to multiply this by something, so this would be a perfect cube. Well, 3 times 9 is 27, and 27 is a perfect cube. So I would get 9 times the cube root of 9 divided by the cube root of 27. And the cube root of 27, this is just 3. So we get 9 cube root of 9 divided by 3. And these two things right here can be reduced. So you're left with 3 times the cube root of 9. If this was helpful, you could click like and maybe even subscribe and visit my website, thebeardedmathman.com. There's all kinds of great math topics discussed there. And if you're a high school student, well, the website's going to have everything you need to get you through high school math from the beginning of your freshman year till the end of your senior year. Anyway, thank you for watching.